Our solar system is haunted by a ghost. Those are not the words of a science fiction writer. They are the chilling conclusions of an international team of astrophysicists led by researchers at Rice University and Sun Yat-sen University. They have spent years looking deep inside the solar system's largest monster, decoding its gravity and tracking its violent past. And they are telling us plainly, Jupiter is hiding a crime scene. For centuries, we viewed our planetary neighborhood as a stable, orderly cosmic clock. But the deeper we look into the history of gas giants, the wilder the cracks in that theory become. We used to think Saturn's violent, planet-spanning superstorms were the peak of cosmic chaos. We were wrong, because billions of years ago, a catastrophic event redefined our entire solar system, the day Jupiter consumed a rival planet. The trouble starts with a structural impossibility. In 2016, NASA's Juno spacecraft arrived at Jupiter. Its mission was simple: peer through the thick, swirling clouds of ammonia to map the planet's solid, rocky core. 2 methods, decades of modeling, same planet. Scientists expected to find a compact rock up to 10 times the mass of Earth. That is how planetary formation is supposed to work. It didn't. What Juno found did not confirm our understanding. It shattered it. Instead of a solid, defined sphere, Jupiter's core is fuzzy. It is a diluted, chaotic soup of heavy elements stretched across thousands of kilometers, bleeding directly into the gas layers above it. Think about what that means for a second. A planet's core is its foundation. It shouldn't just dissolve. For a long time, scientists assumed this was impossible. How do you smash a solid rock 10 times the size of Earth and distribute its remains across the interior of a gas giant? You need energy, an unimaginable, terrifying amount of energy. To find the answer, physicists looked backward, 4.5 billion years backward, to the dawn of the solar system. Back then, space was a cosmic demolition derby. Thousands of proto-planets were fighting for survival, trapped in the gravitational tug-of-war of a growing Jupiter. Supercomputers ran thousands of evolutionary equations forward, trying to replicate Juno's bizarre data. Normal planetary growth couldn't do it. Gradual erosion couldn't do it. Only one scenario fit the data perfectly: confidence level through the roof, a head-on, cataclysmic impact, a rival proto-planet, a super-Earth, roughly 10 times the mass of our world, was pulled directly into Jupiter's gravitational crosshairs. This wasn't a glancing blow. It was a bullet to the heart. The rival planet slammed into Jupiter at a staggering 60 kilometers per second. That is over 200,000 kilometers per hour. Jupiter's outer atmosphere didn't stop it. It sliced through the hydrogen gas like a hot knife through butter. Within hours, the rival world struck Jupiter's pristine, solid core head-on. The impact energy was so fierce, it didn't just break the core. It vaporized it. The rival planet was instantly obliterated, its heavy, rocky remains melting completely and mixing with Jupiter's internal elements. The shock wave reversed the natural settling of the planet's interior, creating the giant, fuzzy, diluted core we see today. A gap of 4.5 billion years, and yet the scar remains perfectly preserved. That might sound like an isolated, ancient tragedy. It is not. If Jupiter hadn't eaten its rival, everything downstream of that moment shifts. The gravitational balance of the entire solar system changes. The orbits of Mars, Saturn, and the asteroid belt alter completely. The timeline for when the inner rocky planets stabilized, when Earth forged its oceans, and when the conditions for life became possible, all of it shifts. You're not just looking at a violent space collision. You're looking at the foundational event that allowed our world to exist. Jupiter didn't just grow to be the king of our solar system. It ate its competition to secure the throne.